In a binary search tree, what exactly is a node's successor? Given some node u, the successor of node u is the next largest node. So it's the node that's just immediately larger than my current node. So for example, in this binary search tree, first of all, we see it's a valid binary search tree because for every node, the node is larger than everything in its left subtree, and it's less than everything in its right subtree. But yeah, so for any given node, the successor of that node is the next largest node in my entire BST. So for example, the successor of A is B, the successor of B is C, the successor of C is D, the successor of D is E, E successor is F, F successor is G, G successor is H, and H's successor is I. If we had an efficient algorithm for determining the successor of a given node, we could use this to implement an iterator that would iterate over our binary search tree in increasing order of size. So how do we actually find the successor of a given node? The algorithm is a little tricky, but let's go over it. Basically, there's two cases. For whatever node you're looking at, if that node that you want a successor of has a right child, you just traverse right once, and then you go as far left as you possibly can. So for example, the successor of E, I would go right once. So let's say I wanted the successor of E. I would go right once. So this is looking for E's successor. Go right once, then go left as much as I can. F is the successor of E. In the case of B, similar story. I go, so let's say I'm looking for the successor of B, or maybe I'll use a different color here. I'll use blue. I'm looking for the successor of B, so starting at B, I would go right once, then I would go left as much as possible, but there's nothing to the left of C, therefore C would be the successor of B. So in the event that the node that we're trying to find the successor of has a right child, it's pretty easy. Just go right once, then go as far left as you theoretically can. The other scenario is a bit more tricky. So if our node does not have a right child, we have to traverse up the tree along its ancestors. And in this upward traversal, the first time we encounter a node that is its parent's left child, we should return the parent as the successor that we're looking for. So what does this actually mean? Let's take a look at maybe node D. Node D is a pretty tricky one. So we as humans can look at our entire tree and see, okay, well, E should be the successor of D. But how did we actually find that? So the algorithm, it says, okay, well, do I have a right child? No, I don't. Therefore, I have to do case 2. So I start here. D is C's right child. Therefore, this parent's left child condition is not met. Okay, let me go up one. C is B's right child. Therefore, this am I my parent's left child condition is not met. I go up to B. B is its parent's left child. Oh, success. I found a node who is its parent's left child. Therefore, I return the parent. So I started here, I went up, and then E is the value that I return. Because B was the first node that was its parent's left child. Let's take a look at A. So A, let me use a different color. So for node A, I start at A. A does not have a right child, so again, I don't do the first scenario, I do the second scenario. Is A its parent's left child? Yes, it is. I've immediately found a successful case of am I my parent's left child? Therefore, the parent is the successor. So B would be the successor of A. It's a bit tricky, but if you do enough examples, it should hopefully make sense.